Yeah, good morning, everybody. Jamie Wallace here. We're going to be looking at lesson 5 with the OSU PDC Pro course here. And yeah, lesson 5 is traditionally one of those really hard lessons. And we're going to go through that today. We'll do our usual sort of overview of the lesson itself, and then we'll take a look at some examples. And the big thing is the micro watershed. The macro watershed that we're asking for is it's pretty easy to come by, and it can be in any. I mean, there's probably hundreds of different macro watershed versions because we can really expand out quite a bit, but the micro watershed is pretty much fixed, and that's what we're going to really focus on. Areas that are above your project site that are directly going to potentially influence your site. So it's pretty straightforward. It took me a little bit of practice to get used to it, but of course I get lots of practice with it now. But so don't get disheartened if if it's not resonating right away. It may just take a little while to get the hang of it. So let's good morning, Andrea. Glad you're here. Let's
Good morning.
let's get right into this, and I will just share my screen, and there we go. We can take a look. Oh, that's not where we want to be. All right. So again, lesson 5 is tricky. I'm going to get the complete file going here. But the survey is straightforward. Should be straightforward to everybody. It's, just talking about where your potable water source is coming from, a little bit about your wastewater, and that 24-hour record rain event, as well as your average annual rainfall. So if you're designing for somebody, you have a client, and this average annual rainfall is something that you definitely want to discover early, as you have with this course. It's all part of our site analysis. And then if you do have access to the record rainfall event, that is super helpful because that will give you at least a baseline of what potentially could happen in terms of your site, the rainfall on your site. And it's very, very helpful from a stormwater management perspective. So where I live, the record rainfall event is about 90 millimeters. So that is just under, it's about 3.5 inches in 24 hours. Now, since we've been living here 28 years, probably about 10 years ago, we had a rain event, a very isolated little cell that came through, and we got about 40 millimeters of rain in 15 minutes. So for you, that's getting close to, that's about 1.75 inches or 1.5 inches of rain, and a very short duration. So with any rainwater harvesting structures or collection that you're going to be doing, knowing these peak flows are really helpful. You can size the system to accept that kind of event. So those are important to take a look at. And another thing that is often overlooked by many people is roofing materials. If you're going to be actively collecting rainwater off of a rooftop, the roofing materials will dictate the reuse of that. So an example would be asphalt shingle roofing. Has a lot of contaminants in it, and fire retardants and hydrocarbons. So that roofing material is not recommended for collection if you're applying to, say, annual vegetables or herbaceous medicinals. Those types of plants can often uptake those elements into their tissues, so you wouldn't want to be consuming that. Now, unofficially, you can apply that water to fruit trees and things like raspberries, plants that have woody components to them. Apparently that's where that some of those pollutants get locked up in the wood, but again, that's kind of unofficial and would it's best to stay clear of it. So in an urban setting, asphalt shingle roofing, one of the go-tos with that would be a rain garden, and we'll talk about that a little bit later today. So yeah, the water survey, very straightforward. It's worth 4 points. And now we get to the tricky part. So if we go look at the template file, and again, this is the hardest part of the assignment. And we're kind of getting everybody warmed up with the first part here, and that is the watershed practice sheet. So I would encourage everybody to take a look at this. There are some tutorials here. And let's see. Yeah, there's a couple tutorials built into this. So I'd recommend you look at that. Water is very predictable how it's going to travel across the landscape, provided we have contour information. And basically, water will flow at a right angle to contour, or 90 degrees. So that makes it very easy to predict how a drop of water is going to flow in this example here. And I'm not going to get too, well, maybe we'll do a little bit of work here. I don't want to do too much of this. But what I do, just make this project site boundary a little more visible. So we'll pretend that's your project site, and we will get a different color here. So what I do when I look at a project site is with this exercise, I always start at the lowest contour elevation. So down here, we've got 440 foot, and we got 470 up here. So this end is where I would start. And we know if any water falls here, that it's going in this direction. It's not going to be part of the, it's not going to enter your project site. But we do know that the bottom, should make that a little bit thicker. Hold on. And a different color. This bottom would represent the bottom of the micro watershed. So as we start to come up, we have to think about the contours that are above us and sort of reverse engineer how this moves. So we know that if a drop of water hits this contour and we have a right angle effect, so it's going to move at a right angle, that this is the way it's going to go. So we're just starting here. So I'm not going to go too much further, but you can tell that if we have rainfall in this area, it's heading in this direction, away from the project site. If we have rain falling here, we know that in all likelihood, it will end up in the project site here. Now, a couple of tips that you'll probably notice as you do more and more of this is when we're going down a slope, and we can tell that by the contours and the labels. When we're going down and we have these contours sort of bulging out, that is a ridge. Okay. When we have the exact opposite, where these contours are coming uphill, that's going to be a valley. So water is going to travel down, not exactly as shown, but water is going to accumulate in that valley and start running. And you can see here that indeed we have a little bit of that effect already. So waters flowing into that valley are going to end up potentially influencing this project site. On the other side here, it's the same thing. We're sort of going right angle to contour, but it's right angle from the higher elevation down to the lower. So it's a little bit of reverse engineering, and then we're going to end up at these peaks here, top of the hill. There's another peak up here, and there's another peak up here and up here. So when you're all said and done, and this is by no means exact, but your micro watershed is going to look something like that. It's quite large. So if this was 5 acres, this would probably be, 60, 70 acres of potential collection. And when we start to calculate how much water that could influence your site with, it's quite startling. So this is one of the advantages of this exercise, and just knowing how to run through this is in essence just knowing what your site could possibly receive in terms of runoff. So let us just erase this. Okay. And we're going to do some practice work other than this. This is a little bit, a lot of people will get this bang on, and then they'll go to do their own, and it's hard because it's a different context. And here we don't have any roadways or ditches or anything like that. So that is another factor that we have to think about, and we'll go over that. So this is the first page, so we definitely want to practice, do this practice sheet. And then your macro watershed, very easy. Really just have to Google watershed, for your area, and you will get a whole bunch of maps to choose from. And it's just a screenshot and throwing it in here, and it's of interest for sure. And you definitely want to point out your project site location on that map. Again, this is very easy. It's probably a 5-minute event for you. So the tricky part is the micro watershed catchment, which is exactly this. This is the same thing. It's just not labeled that way. But this is where we're going to actually take a look at your project site. So I have an example here. So most of you, in fact, I think all of you have contour data for your project site, but now we have to start looking a little bit further afield, so further outside of it. And in the odd instance, you'll find, your project site might be on top of a ridge. You may be the top of the watershed. You may not have any waters flowing into your project site at all, but that is, fairly rare. But so to find that out, what we want to do here, let us presume we'll presume this is our project site. And what we need to do is get some contour information. So using Contour Map Creator, not something I would recommend using professionally, but for this exercise, it's perfect. I've got it set up for 1 foot contours. So each contour is going to be a foot, and I just have to click the various corners of the map and hit get data. So there I go. I've got, and I can move this, which isn't great because now I have changed my project site boundary location. Maybe we can skirt that back in. We'll say it was that right there. And I'll just go up a little bit. Well, I don't know why it's doing that. Try and get it back where it belongs. Okay, well, it's again just very approximate. So we have a legend on the right, and it gives us an idea that blue is low and orange and red are going to be higher. So we know that we're quite low on the landscape here. And let me get a color that's going to show up. Go. So this at the bottom is the lowest part of the landscape, and that's where we're going to start our boundary, our micro watershed boundary. And then look at the angle of these contours here. They're telling us that any water that hits this location is going away from our site. So the bottom of our micro watershed is along the road, and then it's going to come up the side here. So we've done 2 sides already. That was easy. And then once we're in this corner, we can see that it's going to respond a little bit. This is very quick, and it may not be 100% accurate, but it's going to give people an idea. And I'm going to stop there, and then I'm going to go to the other side here. And instead of coming right up the property boundary, you can see these contours are sort of angling towards the boundary, which means if we have rainfall here, it's going to clip the project site here. Yeah, again, this is not, I would normally be spending a bit more time on this, but I think people are going to get the gist of it. So when we come out to this edge, you'll notice there's a road, and that road is going to be a constraint. Okay, so regardless, we're going to assume that road has curbs and catch basins. So water hitting the road is not going to come onto this property at all. If it did, we might be going down the middle of the road, because most roads are crowned, which means water is going to flow in one direction and the other. So we're going to just head up here, and not the nicest lines, but in essence, that is our project, our micro watershed boundary. And then this inner portion here is the basin. And again, this is a little bit on the crude side. So what we can do now is calculate the size of this We can do that on Google Earth if we want. We can calculate the size of this, and that'll tell us approximately what annually, what the annual rainfall data is for here, plus that 24-hour event. So if we apply the right coefficient factor, so what that is when water hits a surface, how much of that is going to be absorbed and how much is going to run off. So now I realize I've made a quite a large error here because I was moving this around and I've crossed this road here. So we'll just imagine that road wasn't there, Ellesmere. If that was the case, our micro watershed would end right at the road. But this is the property I was supposed to be looking at. And we can do that all over again, or we can do another one. I am happy to take a look at anybody's project site if they want to put the address in the chat here.
Sure. I'll put it in there.
Yeah.
Give me a second though, because I don't memorize it. Is anybody else? I can't hear anybody else on the call.
I think Dana's driving, so it'd be hard for her.
Okay.
So yeah, if anybody wants to throw their address in here, we'll
I'm no longer driving, so.
Oh, there you go.
We're good.
Okay.
Yeah, if anybody has, oh, there we are. Natalie's got, okay, so we'll just copy that address. Uh-oh.
906 A.
It's 4 ones. It's 1111.
1111. Okay.
Yep.
Now, the one thing that's always a challenge is finding it. Do you know what?
I do believe that's it right there.
Right in
right
here?
Where your cursor is. Yes, it's on the southeast corner of that intersection.
Right over here?
Oh no, sorry. It's the northwest segment of that intersection, and it's the northeast plot in that little section there. So right where your cursor was. It's that one that has all the black tarps in the front yard.
Right here?
Yep.
Yeah.
Mm-hmm.
Okay, well, we'll put we'll assume it's about here, is that right?
Yep.
Okay. So these, when we get into urban locations, again, it's pretty straightforward because we know we have catch basins and curbs, and this is traditionally the way water is managed in an urban area. So we're going to just get contour data. Uh-oh. I did not do an important first step here. I have to reload Contour Map Creator. It doesn't like to. There we go. There we go. And we just got to make sure we're right overhead. That should do it. Okay. So we're going to be on feet, and we'll do 1 foot. If you're on a bigger site like Andrea, you might have to do 5 foot, 20 foot, all kinds of options there. We're going to get data from this area. Okay, I did that wrong. Wow, that is a flat spot. So I might even say going 0.5. All right, let us zoom in here a little. Okay, so we're going to put our boundary here. We'll just say it's that. And then we are starting at the low point. Orange. Okay, so here is the low point. So, yikes. Wrong tool. There we are. So we know those are basically our two, that's our corner. And then we're going up in elevation. So just judging it by this, looks like we're heading in that direction. And we're gonna probably pick that up. Oops. I don't have a way of correcting that mistake, but that would be approximately what we're looking at. Again, because I'm kind of on the fly here. And then inside of this is our boundary or basin, sorry. So the orange is the micro watershed boundary, and the inner part is the basin. So anything hitting the basin could potentially hit our project site. Looks like Natalie's got a question here. You go ahead. Oh, I can't hear you, Natalie. You go ahead if you have a question.
See.
Oh, I can hear you now.
What about now?
Sorry, you're kind of cutting in and out. Can you try again?
Yeah, let me move to a different part of the house. So am I correct in that everything within the orange boundary is my watershed, like it's coming into my property?
Yeah, it could potentially, right? It's not for sure, but yeah, that would be a very quick and dirty map of the of your micro watershed. It'll be in and around that.
Okay, cool.
Yeah.
Because I was wondering that because like I live in a neighborhood, and so like there's a lot of I don't know, like there's a chicken coop within that area that my next door neighbor has. There's different gardens and different buildings and everything. So I was wondering how that would affect the water flowing in.
Yeah, well, it will come off that building onto the ground, and then if the ground is within that micro watershed, it could potentially enter your project site. Now it's all potential, right? So let's say we had a record rainfall event, you had 4 inches in a day, and your soils are saturated, and most likely in an urban area, they're a bit compacted. You might find that, you know, you potentially could get 10% of the water that's hitting that area that might end up coming towards your project site. So that's one of the pieces we're not talking about at the moment. I'm just going to get rid of what I've doodled here. If we go to the site water flow section, you'll see that we want your roof areas, the material, the size of it, and then your annual average rainfall. And then there's this coefficient runoff number. So there are tutorials on that you can look at, and there's a table here. Let's look at that table. So here's the factors. So metal roof is often, 0.9 or 0.95. I would say that's incorrect. Asphalt's lower. It's like 0.75. It really doesn't matter whether it's a digit one way or the other for this exercise. But these are all the roofing types. You can see when we get into soils, their factor's a lot lower. So if you have sandy, rather flat soils, which yours had, not sandy necessarily, but it was pretty flat, that the runoff is going to be much lower. So if you calculate that potential volume here, that's what this is all about. And then this coefficient factor number, you include, say, 0.1, it's really just going to be a tenth of whatever if it was 100,000 gallons that could come onto the site, it would be 1/10 of that. So just if I'm probably not explaining that as clearly as I can, but the formulas here, so it's A, our area, times B, the average annual rainfall. So that's going to be either in feet or millimeters. So that's tricky. You got to convert your inches to feet and then times that by the coefficient factor, D. And then you have to also convert that to gallons. So you got to go times 7.48. So if you're using imperial or US units, you want to use that. And then if you're metric, it's much simpler, but it's different, right? It's liters and millimeters. So that's, hold on here. Yeah. So in both cases, you're factoring in this coefficiency. So when we're doing rainwater harvesting designs, we look at the roof type. And let's say where I live, we've got a metal roof. So we calculate that potential collection, say for the year, and multiply it by 0.9 or 0.95. And that would give us our potential collection. If it was an asphalt shingle roof, I would probably use 0.75. And of course, that number, the total potential collection would be a lot lower. But the material that you're collecting from dictates how much of that you're going to receive. Because asphalt shingle, it absorbs quite a bit, and there's splash and there's other factors involved. But metal's pretty good that way. I don't think it's listed here, but also, yeah, there's also a living roof. So I have a friend who's got a green roof, right? And that has a coefficient factor of about 0.1, very, very low, because a lot of that water, when it hits the roof, is absorbed into the growing media and into the plants. But about 10% is going to run off. So yeah, this is a good resource. It's not absolutely perfect, but it doesn't really need to be. It just going to give you a very general idea of what to expect when water is in and around your project site. Yeah, so go ahead, Andrea.
Is this rainwater harvest runoff coefficient table available in the homework?
This table here?
Yeah.
Yes, it is. If we go on to the template file, you'll see it's right at the bottom here. Highlighted.
Right, great. Okay, thank you. Oh, there it is. Yeah. Runoff. Okay.
Yeah. So that's it. It's a good resource. I've seen slightly different numbers. Doesn't really matter. It's pretty hard to prove one way or the other. But I do know we used to have asphalt shingle, and the volume of water coming off of our roof is dramatically different with metal. So yeah, so that's a great resource. Go ahead, Dana. You have a question?
Yeah, so when we're doing our micro watershed in an urban setting, so are we ignoring like all the streets?
Yes. Well, you actually you're paying attention to them, but they're a constraint. So if we take a look, say at Grant Avenue here, and the way, if you go and take a look at a section view, like if you're standing on the road, looking at it carefully, you'll see that the road has a crown in it. And that is to drain water off it properly. So if this was midpoint, we're going to have water go that way, and we're going to have water go this way. If you were building a road in your homestead, this is a nice way to do it. So you're not going to have, you know, potential damage on the road. Water is always going to be skirting off and hopefully into a little ditch or a curb or what have you. So if we drew a line down the middle of Northwest Grant here, we know water's going to head off in that direction. And there's probably a catch basin somewhere around here. So all that water is going to run along the curb and then into a catch basin and out to the stormwater system that is in Corvallis. So that's basically how that would work. That's why we would tend to ignore the roadways. Now, the opposite would be true if we were looking at a parking area. So if we back out a little bit, let's see if we can find, now there's no shortage. We've done rain gardens for parking areas before, and we'd actually be doing the opposite here. So we would need to, if we were, say we were planning on the same thing, maybe there's a ridge along this part of the parking. So water's going this way, and I'm just making a presumption. And it might get picked up on this curb over here. And perhaps there's a catch basin at the end here. And if we were needing to figure this out, you know, it's quite possible that our micro watershed, say for this space here, it could be this, and maybe our rain garden's going here, and it needs to be based on this area. So we'd probably want this to be at least 20% of the size of this part of the parking. So that's where it's opposite. If you're dealing with parking lots and you're trying to remediate the pollutants in a rain garden here, you'd definitely be calculating all of that. If you're in an urban site, these roadways are constraints. We know that the rain, with most of these stormwater systems, we know that rain will not jump the road to the other side. So that's why we want to pay attention to the roadways in this. Now, that gets a little more complicated in rural areas. Let's go out a little bit. Let's say we are here and we have roads on this side. Now, in rural areas, often we're dealing with roadside ditches or culverts going under the road, right? So there might be a culvert under here. So the calculation here may be a little bit different, right? We may be picking up water in this area. It may end up going under a culvert and dumping onto the project site. Let's say the project site was this big cleared space here. So it does get a little different when we're into bigger areas, but do factor in these roads. Another thing we want to factor in is riparian waterways. Let's see if we can find. And this makes it a lot harder. Here we go. We got a river. So let's say there's Mary's River, and let's say we have a project site that goes right across the river. Funny enough, there are some project sites that do that. And we'll just presume that we're going uphill in this direction. But we have roads here, so normally, if we're calculating this, we may, let's say our contours, sorry, got to get another color here. Let's say our contour data dictates that that this would normally be our micro watershed, right? And we're like, well, that's what the contours tell us. But what we got to also consider is this river is coming directly through the project site. And then in essence, water flowing into this river is influencing our site. So in this case, our micro watershed may be pretty large, and hence the challenge that some people will have living close to a river with flooding in certain situations, right? They'll have so much runoff upstream that when it does hit their site, it's a brutal impact, right? So that's a scenario that can definitely happen and does with a number of students' sites. I would say if you have a river going through your site, then calculating this gets really quite vast. It can be very, very large. If it's a stream or a creek, it's a lot easier, but you can see the river, and I'm just presuming this is the direction of the river. It may be the opposite, right? I don't know for sure. Looks like it's, but as you can see, it is, there's quite a bit of water here you'd have to track down. So, but it is vital to know this information, especially on these larger rural properties, if you have water flowing into it. So what could you expect in the event of a record rainfall? And maybe it's a record rainfall with snow melt as well. I mean, it could really cause some challenges to your project site. So if you have rainwater harvesting structures in place and they're not sized appropriately, they may fail, they may cause some challenges for structures that are on the site itself. So you do want to be mindful of that. All right, so Dana, let's take a look at your site here. We'll see if this lets me. There we go. Okay. Where are we? There we are. so we're on 40th, so we're right around here somewhere. I don't know exactly on.
Yeah. Like in between Stewart Street and like that other
and here?
street, like, no, down.
So here.
It's like,
Aha, there it is.
yeah, right there.
Okay, so what we'll do is I'll include the whole block, and we will get a project site boundary here. We'll just it may not be exact, but close enough.
I had a question though about like the macro watershed in
Yeah.
terms of like the urban site. So it says to include like the largest river basin. Like for my site, like how do you find that?
Okay, well, let us I'm going to get rid of your site boundary. Yeah, that's actually one of the easier things to do. And then if we look under images here, that could be categorized as one. It's a macro watershed here. There's often some beautiful maps. That may or may not be in your area. Takes a little bit of, like there's
Okay.
that's a huge one, and that's completely fine doing that.
Okay. And then like, so like with those, we would just ignore all the streets for that?
Yes, because we're looking at macro, not micro. So they are quite different. The macro is going to be more area specific. And if we were looking at this closer, in all likelihood, there's some sort of ridge all the way along here. There'd be a high point or a ridge that would be enclosing that micro watershed. So water hitting the other side of the ridge is going into another area. Water hitting here is going into these tributaries and making its way through the area in general. When we're doing, I can show you an example of, this is something that we do with our designs. We often will show the macro and micro, and it can be quite, let me show you that. Well, actually, we didn't finish off your micro watershed boundary here. We should do that.
Oh, that's okay. If we don't have time, I think I can figure out the boundary for that.
Okay. What I'll do, I'll just see what it looks like if we do 1 foot, and we're just going to go on the block, right? We'll stay to the block. So there's a bit of grade change on that block. So maybe we'll go to 2 foot, make it a little clearer. And your project site is right around here. So you can see there's a high point in this area. So this is pretty straightforward. If this, no, I think I'm wrong there. So right here, yeah.
Yeah.
And it looks like there's an alley. Is that correct?
Yeah, I think so.
But we'll presume the alley hasn't got catch basins and that water would flow over that. So if we were doing this, here's our low point, and we're coming up here, and then we're going to, and this is very rough and quick, but this is the top of that ridge, and then this is it's going to be something like that. So, which is
Okay.
a fairly decent size. Now, because it's an urban setting, you know, you may actually not ever see any water travel from here into the project site itself. But you could potentially see it up through here where all this lawn area is. Anything that hits these rooftops is undoubtedly going into the storm system. So yeah, that gives you a little bit of a rough idea with that. I was going to do something else and I've forgotten. Sorry.
Thank you.
Yeah, no problem. So it is pretty straightforward. Again, these roadways are constraints, and that's just one thing you want to keep in the back of your mind when you're doing this. But again, it's water moving right angle to contour, and that makes this quite predictable. I'll just see if I have an example I can show you here. I'm going to stop share with that, and didn't have it set up beforehand here, so okay. I'll just show you one that this is a design we did for a couple close to where we are. So I'm not sure why that is in there. That shouldn't be there. Gosh, this is a different drawing. Same thing though. So in this situation, let me just get my pen. So the blue line here is our project site boundary. And you can see contour data here. And I think this is 1 meter contours. So that would be about, you know, just over 3 feet. And gosh, that is not the right map. Sorry about that. Let's see if I can. Too many files. Getting closer now. Okay. Here we are. Okay. Yeah. This isn't the best example, but this is a water layer we did for a client, and you can see down at the bottom here is the micro watershed. And you can see this is the project site. And then all of this is the micro watershed based on the contour data we were able to get. So you can see this is a small urban spot here, but the micro watershed is quite large. And in fact, it is. I will show you here what happened on this project site. Okay, and then that we're going to call it a day when I get, here we go. So we had a project here that we needed to put in new retaining walls, which we did. And it turned out great. Oh my gosh. I have a shot here that during the winter, what happened, our mason made an error behind that retaining wall. There we go. And this is what happened. All of a sudden, we're getting winter rains, and this is just before Christmas. And we started getting water just sitting right below the pavers, and you can see it was moving across the paver here. So this is not good, right? And we knew that this would happen if we didn't drain this wall correctly. So it was drained correctly the second time, but and it turned out well. And actually the second time around, what we did was we ended up just to be safe, we put in a little bit of a elevation on the planter here, and there's a drainage basin below it. So you can see the slope here, and this goes back up into a park, and that is what our micro watershed was showing here. So huge amount right here, annual average collection. So that's the road, sorry. Looking for the micro watershed. I guess I don't have the calculation on this page. Oh, there it is. So 3.2 million liters is the potential runoff at 10% over annually, right? And I believe it. There is a lot of flow going through this area, but totally invisible during the summer months. And because there was a retaining wall uphill from the house, this was a clue that we needed to be really careful with walls. You always have to be careful with walls, but this did, give us a good heads up with that. Okay. Yeah, so we are getting right at the end of our time here. Does anybody have any questions about the micro watershed? Anything they don't understand? Or I'm sorry, Andrea, we didn't get to your address here. We can take a quick peek if you want, but I know
That's okay.
yours
We had some good examples, and I can see the flow of the water, I think, pretty well on the contour.
yeah. Yeah, and that's again, it's at a right angle. I think in your situation, you'd be having to zoom out quite a bit, the surrounding area, just to see what's going on there. It seems to me you have a dry ridge and it goes down into more moist area. Might not be as big as you think, but
Yeah,
Yeah,
the top of the hill above the site is part of the site, so there's not much up above that. I
right,
think we might be the top.
right. Yeah, and it's surprising sometimes that does happen where the site is the top of the watershed. And it's a great, it's very helpful to know that. You don't have to wonder why you might be a bit on the dry side, right? If that's the case. So,
Yeah, that's just, yeah, half the property is the dry and then half the property is the forested area, so it
right, which
collects.
is naturally going to hold it
Mhm.
more. Okay.
I
Well,
think this
that's
is a very interesting and exciting assignment. It might be difficult, but I'm very interested in how to uh, understand water path and understand the usage of water and how to catch it. And if we want to do catchment, then this is a huge assignment for that.
yeah. And and this assignment is going to change a little bit over time, probably within 6 months or a year. This assignment will include not only looking at your micro watershed, but design ideas, because that's something we're not doing here, and that's something that all of you can do. Is just think, okay, here's all these resources, either coming off a roof or coming off of neighbor or through a ditch or riparian. What can I do to slow that down and make better use of it? And yeah, that's a good step to go through, even though it's not part of the this particular assignment right now, but it's good to
It's
be
going to
thinking.
be in the future.
It will. And it's going to kind of catch up to us because we're going to go through it. We're going to have a break now for about 3 weeks after this assignment, and then we're going to come back and go through lessons 6 through 10, but we're not really going to be applying any skills, design skills until a bit later, like lesson 8, 9, and 10 are when we start to really get into it. So we want to remember and prioritize water. Yeah.
So over the break, our next assignment is not due until the end of September,
Right.
right? The due date is actually the end of September.
Yeah. So what we'll do, we will lesson 5 is due next Monday. So we'll submit and I'll grade those, and then we'll have a break. And then as we come back, we'll do a Q&A for lesson 6, which it's a much easier assignment. It's kind of an easy step back into the course after a little break. And then we're into it. We get probably 8, 9, and 10 are the hardest of the second half, but yeah, so you get a nice break, and that's always good. Have a little breather. For some people it's really good because they can get caught up if they're behind, but all of you are keeping up, and that's great. You get the most out of the course that way.
It seems
Yeah.
like this class time has less people. Is the summer, fall a smaller cohort?
Yes, spring and summer are class sizes tend to drop a little bit. This class started as 25 people, but really, I think there's only 5 submitting assignments. And you never know. I mean, that's the lowest proportion that I've seen since I've been doing this. But yeah, a lot of people just like to look at the content, and they're comfortable with that. If you're wanting to, to design for others down the road, then it's a really good idea to do the assignments and get feedback and take advantage of these Q&As and get your questions answered if you have any. And yeah, so it's different with every single class. Sometimes we'll start with, it may start with 30 people and you have 20 get to the end. It's just completely random. And it's a lot of work, right? So, and some people, I don't know, might be better suited with the other class. I have no idea, but this is for folks that want a good start, and yeah, we do our best to point people in the right direction that way. So
Yeah, I found it very valuable and I've learned a ton.
cool.
So it's been really great.
Yeah, and you'll probably feel at the end of the class, this is just the beginning of learning. And then you start doing, doing projects, and yeah, they're fascinating. I mean, even I'm involved with one right now where I'm doing stuff I haven't done before, right? So doing more sort of what's called pit planting, where the site is so sandy and so dry, we're trying to collect and send our water into a lower little planting basin, but got to be very
Yes,
careful.
I've seen videos about that where they're greening the desert in Africa using pits or half moons.
Yeah, that's one way. Yeah. Yeah. And if you look at Brad Lancaster's work, it's not going to focus, but anyways, he has some great examples. But yeah, taking strategies from dry climates and putting them into this one, which is dry during the growing season, and then we're inundated through the winter. That's the tricky part. You want to keep your plants alive during the winter, and so yeah, it'd be very interesting. We'll see how it goes. I'll hopefully I'll have my water layer done in a few weeks, so maybe I'll share that with everybody in our next Q&A.
Yeah, that'd be great. I'd love that.
Yeah. Okay. Well, I hope this has helped people with the assignment. And if you do have any questions at all, if you get stuck, let me drop a link in the chat here. Sorry, just looking for it. Sorry, I'm just trying to get this link. I do not know why it is not cooperating. Well, I will give you this link, and you just click on. There we go. Yeah, if you need help, you can just click on that link and go to the OSU box, and then it will allow you to schedule a little one-on-one Zoom meeting if you need that. So I certainly offer that for this lesson. This is where a lot of people get stuck. Okay. Well, thank you very much, everybody. And you have yourself a great rest of the week. And look forward to seeing your assignments next week. So thanks
Thank you very
again.
much.
Okay. Take care.
Bye.
Thank you.
Okay. Bye-bye.